Okay, so today we're going to be looking at further equations of lines. Okay. So further equations of lines. Now basically you're not always going to be given the gradient or the intercept of a line. You won't always be given it to you as an equation. Sometimes you actually have to come up with the equation yourself, like we looked at the other day. So we remember that y is equal to mx plus c is the equation of a line with gradient m and y-intercept c, and we can rearrange that into into general form by moving everything to one side and removing all fractions. So sometimes you might be given the gradient or the intercept, or you won't be given 2 points to work it out. Sometimes you might just be given the gradient and a single point on which which lies on the line. And so we can work out what the equation of that line is by doing point gradient form. So the line with gradient m through the point x1, y1 is y minus 1 is equal to m lots of x minus x1. And now we can get to that equation quite easily by just looking at the gradient formula. So we know that gradient is equal to y2 minus y1 over x2 minus x1. Okay. And I can rearrange this by multiplying both sides by x2, x1. So m is equal to, we get x2 minus x1, lots of m, is equal to y2 minus y1, just like that. Okay, so if you've been given a point and you don't know what your other points are, okay, so we're going to call our point P, x1, y1, and the other point is just x, y, because we don't know what the second point is. This is our mystery point. And if we just substitute those in, we get m lots of x minus x1, which is equal to y minus y1, just like that. Okay, and so that's how we come up with that equation there. Now this stuff is just basically explaining that. But the only time you can't do it is when you are given a point. If you try to work it out with with 2 points, with 2 different points, you can't do that with, I don't actually know why I wrote that out. Anyway, you can't actually do that with a point that is the same on the other one. Okay, so here's an image of just what we did. So here's my point that I've been given. I know that all of these other points are points that lie on the line, so let's just pick one at random and we'll call that x, y. Okay, so by substituting those into the gradient and rearranging it, we can rewrite our equation in gradient intercept form. Okay, so as I was saying, the only time it doesn't work is if this one here is the same as this one here. So if the number that you pick, or the point that you pick, is the same as the one there. Okay, I'm just going to increase the thickness a bit. Okay. Now, the line through 2 given points. So if you are given 2 points, okay, what you need to do, and you asked to find what the equation of that line is, all you need to do is find the gradient. So the gradient is the first thing that you need to do. Okay, I'll make it a bit thicker again. So the gradient is what you need to do. Find first. And then the equation using point gradient form. Okay, so then you just have to use one of the points to work it out. Now the last thing that we're going to be talking about is concurrent lines. So 3 distinct lines are called concurrent if they all pass through the same point. So to test whether the 3 lines are concurrent, first find the point of intersection of 2 of them, then test by substitution whether the third point, or whether that point lies on the third line. Okay, and that'll be a lot clearer when we do our examples. So example 1, find the equation of a line through 420 and perpendicular to y is equal to mx plus 2. And then we're going to express the answer in gradient intercept form and hence find its y-intercept. So we'll start off with that first bit. So part A, okay, find the equation through the line. So what we're going to do is we're going to find what our gradient is first. So we know that it's perpendicular to this, and we remember that perpendicular lines, their gradients, when we take the product of both of those, are equal to -1. Okay, or in other words, m1 is equal to the negative reciprocal of the other. So if my gradient is 3, then my negative reciprocal, or my gradient, my second one, is -1 on 3. Now, what we're going to do is we're going to use our point intercept So a point gradient form to work out what this one is. So that is, we're going to go y minus y1 is equal to m lots of x minus x minus x1. Okay, so all we have to do now is we need to replace our gradient with the gradient and replace our point x and, let me do it this way, x and y into our equation. Okay, so the y and the x are going to stay as they are, and they're going to become the variables of this relationship. So we're going to go y minus, okay, our y1 is 20. Okay, that is equal to negative a third lots of x minus x1 is 4. Okay, and so we're going to leave it like that. And so that's an equation in point gradient form. Now part B says we're going to answer this in gradient intercept form. So that is, we're going to move the everything to the right hand side except for the y. The y is going to stay by itself. Okay, so first things first, I'm just going to rewrite my equation. Y minus 20 is equal to negative a third lots of x minus 4. So first things first is I'm going to expand that gradient out into the right hand side. Okay, so that gives me y minus 20 is equal to negative a third x minus, and the negative become plus, so plus 4 on 3. So 4 times a third is just 4 and 3. Now I need to remove this minus 20 from the left hand side, so I'm going to add 20 to both sides, so add 20 and add 20. So that gives me y is equal to negative a third x. Now plus 4 on 3 plus 20, so 20 is the same as 60 on 3, so 60 on 3 plus 4 on 3 just becomes 64 on 3. So therefore, my y-intercept of this equation is 64 on 3. Okay, and that's it. So that's how we work it out. Okay, example 2. For the points 1, 7 and negative 4, 5, find the equation of the line passing through these points and the equation of the perpendicular bisector of AB in general form. So we'll just start off with part A. So the equation going through a line. So because we've only been given 2 points, what we need to do is we need to find what the gradient between these 2 points are. So M is equal to, you might remember from the other day, that our gradient formula is y2 minus y1 over x2 minus x1. So I'm going to call these 2 points. I'm going to go x2, y2. Now remember, it doesn't matter which one you call x2, y2 and x1, y1. They're both going to give you the same answer for your gradient. So 5 minus 7 over negative 4 minus 1. So my gradient is negative 2 over negative 5, which just means my gradient is 2 over 5. Okay, so m is equal to 2 and 5. So now what I'm going to do is I'm going to put this into the gradient, point gradient form. So that is, not y2, y minus y1 is equal to m lots of x minus x1. Now I know what my gradient is. My gradient is equal to 2 on 5, so I can replace that with y1 is equal to 2 on 5 x minus x1. Now it doesn't matter which point I replace, the negative 4, 5 or the 1, 7 into the other parts. Okay, but because I've already got the ones labelled, I may as well just use that point. So y1 is equal to 7, so we get y minus 7 is equal to 2 on 5 lots of x minus, and x1 is 1. Okay, now that is enough. That is an equation that is true for this line. If you wanted to simplify it further, you can, and it might be worthwhile because in part B, we're actually asked to find the equation of the perpendicular bisector. So we need to know, well, we don't really need to know because we know what the gradient is already, but just as a general rule of thumb, when you're answering these questions, we typically like our answers to be either in gradient intercept form or in general form. So we will do that. And it's a good practice too. So y minus 7 is equal to 2 on 5x minus 2 on 5. Okay, add 7 to both sides, and we'll leave this in gradient intercept form. That gives us 2 on 5x. Okay, and now we know 7. So if I'm going to add 7 to both sides, I know that 7 is the same as 35 on 5 by multiplying, remembering that 7 is the same as 7 on 1. Multiplying the top and bottom by 5 gives me the same thing, so it's going to be equal to negative 2 plus 35, so it gives me plus 33 on 5. And so my gradient is my equation is y is equal to 2 on 5 plus 33 on 5. 2 on 5x plus 33 on 5, okay? So that's part A. Now part B, the equation of the perpendicular bisector of AB in general form. So the equation of the perpendicular bisector. So we know perpendicular, and we did that in the last question. Perpendicular just means that m1 times m2 is equal to negative 1. Or in other words, as we know, m1 is equal to the negative reciprocal of the other. So I know it's 2 on 5, so the negative reciprocal of my first gradient is negative 5 on 2 by just flipping it around like that. Okay, so flipping the 5 and the 2 around. Okay, so swap those side around and then put a negative on the in front. Okay, so we found that. Now, we need to find the perpendicular bisector. So we actually need to find the point halfway between A and B, because the bisector is where this line cuts between an interval halfway. Now you can't find a perpendicular bisector of an equation of a line because a line goes on forever. So technically it would just be through 0, which would be, easy, but we're asked to find it of AB. So between the points A and B. So I'm just going to write A as 1, 7 and B as negative 4, 5, I want to say, from memory. Yeah. Okay. So to find the perpendicular bisector, we need to find the halfway point between A and B and then use our perpendicular gradient to work out what our point is. So our midpoint of A and B is x2 plus x1 over 2 and y2 plus y1 over 2. Okay. So that is minus 4 plus 1 over 2 and 5 plus 7 over 2. Okay. So minus 4 plus 1 is equal to minus 3. Minus 3 divided by 2 is just negative 1.5. And 5 plus 7 is 12. 12 divided by 2 is 6. So we can see that one's halfway, because halfway between 5 and 7 is just 6 anyway. Okay. So we've got a gradient, we've got a single gradient, and we've got a single point. How do I find the equation of a line with just a gradient and just a point? Hopefully you're thinking to yourself the gradient or point gradient form. Okay, so that is y2, not y2, okay, we're going out. Y minus y1 is equal to m lots of x minus x1, okay? So we've got our m, which is negative 5 on 2, and we've got our point over here. So our midpoint is the point that we'll be using. So let's call that x1, let's call that y1. Let's substitute these values in. We get y minus 6 is equal to negative 5 on 2, lots of x minus 1.5, okay? So just like with our parallels and stuff, we're always doing the opposites on the inside. Now we want to find it in general form, so we're not just having this equation, we need to rearrange this so that everything is on the same side now with 0 left on the other. So what I'm going to do is I'm going to expand the right hand side out, so we get y minus 6 is equal to negative 5 on 2x plus 1.5 times negative 5 on 2. Well, 1.5 is the same as 3 on 2. 3 on 2 times negative 5 on 2 is just negative 15 on 2. So we're going to change that plus to a negative, and that's going to be 15 on 2. Now we need to add 6 to both sides, so plus 6 and plus 6. And that gives us, so 6, y is equal to minus 5 on 2x. Okay, so 6 is the same as 12 on 2. So if we're adding that to 15 on 2, that's going to leave us with negative 3 on 2. Now we're going to move the y to the other side, so it's going to become negative y minus 5 on 2x minus 3 on 2. And because we don't want the fractions, we're going to multiply everything by the common factor of our denominators, which is just in this case is 2. So we multiply everything by 2, we get x0 is equal to negative 2y. 0 times 2 is negative, 0 times 2 is just 2. 2 times negative y is negative 2y. Okay, negative 5 on 2x times 2 is just negative 5x, and that leaves us with minus 3. And the last thing we're going to do is, if I was then to move everything onto the other side to make it positive, we'd get 2y plus 5x plus 3 is equal to 0, just like that. And that's in general form the equation of the perpendicular bisector between the points 1, 7 and 4, 5. Okay, last but not least, we've got a test of whether some lines are concurrent. So L1, or line 1, is y is equal to 3x minus 2. Line 2 is 3x plus 2y is equal to 14. And line 3 is 5x plus a half y minus 12 is equal to 0. Now, looking at this, 1 and 2 look a lot easier than 3, so I'm going to actually do simultaneous equations with line 1 and 2. And then whatever point I find from those, I'm going to substitute into line 3 and see if it works. So y is equal to 3x minus 2, and 3x plus 2y is equal to 14. Let's call this equation 1, we'll call this one equation 2. So when we do this, what we're going to do is we're going to substitute equation 1. So we'll substitute equation 1 into 2, because we've got y is equal to 3x minus 2. Okay, all you need to do is replace it. So we're going to get 3x plus 2 lots of 3x minus 2, and that will be equal to 14. So we're going to rearrange this by expanding and simplifying. So we get 3x plus 6x minus 4 is equal to 14. Well, that's just the same as 9x is equal to, that's the same as 9x minus 4 is equal to 14. Okay, adding 4 to both sides, we get 9x is equal to 18. And then last but not least, we're going to divide both sides by 9, and we get x is equal to 2. So that's our first point. Now, are we done? No, of course not. We need to find what our second point is. So what we're going to do is we're going to substitute that into either of the first two equations. We're not touching this one yet. No, bad. Cross him out for now, if you have a erasable pad like I do. Ignore him for now. But we're going to substitute x is equal to 2. We can do it into either this one or this one, okay? So pick the one which is easier, obviously line 1, because it's already got it in the form y is equal to 3x minus 2. So substitute x is equal to in that, we get y is equal to 3 lots of 2 minus 2. So y is equal to 6 minus 2, so y is equal to 4. Okay, and that is my second part. So the point 2, 4 works for L1 and L2. Okay, so to check if it works for line 3, all we have to do is substitute 2, 4 into L3. Okay, so this is where we can construct that one. So we get 5x plus a half y minus 12 is equal to 0. We're going to substitute the point 2, 4 into there. Okay, so this is my x, this is my y. So 5 lots of 2 plus a half lots of y minus 12 is equal to 0. So if the left-hand side is equal to 0, well, not y, 4, which is what y is equal to. So if the left-hand side is equal to the right-hand side, then we have a true statement, and then that means that that line also passes through that point, which means that the 3 points of intersection are at that line. So let's look at it. We've got 10 plus 2 minus 12 is equal to 0. 10 plus 2 is 12, so 12 minus 12 is equal to 0, so 0 is equal to 0 as required. So just one sentence to finish it off. Therefore, L1, L2, and L3 are all concurrent, as they all pass through to 4. Okay, that's it. So these will all be on your OneNote so that you can look at and follow along as I do it too, if you've got the benefit of 2 screens, or you can just watch what I've done. Okay, the good thing about this is you can literally replay and rewatch what I've done. But this is our first lesson for today. Okay, so because this is the Thursday lesson, or Thursday day, we actually got 2 lessons to do. And the second one's a little bit harder. But with that being said, have a go. And that will be 7D for today. Cheers.